myself Samati, and in this video, I and my group members would like to share with you the project we worked on during our online summer internship at Bennett University under the initiative of Leadingindia.ai. But first, I would like to express my gratitude to Bennett University and Leadingindia.ai for providing us with this opportunity. I would also like to thank our mentors Mr. Deepak Ray and Ms. Shubhangi Rustangi for helping and guiding us through all the hardships that we faced through the development of our project. The title of the project we worked on was Fake News Analysis Modeling. As time flows, the amount of data, especially text data, increases exponentially. Along with the data, our understanding of deep learning also increases, and the computing power enables us to train larger or complex models faster. Fake news has been gathering a lot of attention worldwide recently. The effects include social, political, economical, organizational, or even personal. This project proposes a model to identify a variety of features in terms of spreading information from Twitter, a social media platform with a good deal of power in terms of spreading information. Here, fake news was analyzed through neural network-based classification by using the preprocessed data and the identified best features in the learning data. The contributions of our project includes pre-processing the data, identification and extraction of novel features, application of neural network-based classifier, and finally a test model to classify tweets into fake and real.
This is Saryo. We need some data to train the model. For the data, we have downloaded the datasets from kaggle.com. The datasets we used are one real news dataset and the other one is fake news dataset. These datasets contain headlines of real news and fake news, Twitter respectively. So we have extracted some features that we require for our model. For each headline, we have collected 20 tweets related to the headlines from the datasets we have downloaded from Kaggle. Also, we have taken like number of followers, number of likes, number of retweets for the particular tweet. We have collected this information using Twint, which is a web scraping tool, and we have created our own table.
Detecting fake news is a difficult task due to the subtle difference between real and fake news. As a first step, we chose to focus on tweets from two different perspectives, that is, its source and the content of the tweets. Actionable features were extracted using visualization techniques like box plots, scatter plots, and bar plots to see if there is a noticeable difference in trends in features which are common to both real and fake news. We found that using just the language or the content of the tweets will not be sufficient because, as I said, the difference between them is too subtle to be captured. Next, we visualized retweet propagation graphs and user interaction networks to see the difference between engagements for real and fake users. After analysis, we decided to include additional features in our model like the engagement the tweets received, the average engagement the user receives, the sentiment of the tweets, and the characteristics of the tweet like the number of mentions, punctuations, and the number of useful words in the tweet.
So the model that we used was MLP, multi-layer perceptron model, based on the scikit-learn library. Our data had two aspects, the user aspect and the tweet aspect. Like we made three models using this. The first one was based on user, the second one was based on the tweet features, and the third one was a combination of these two. We added features to our model iteratively and chose the best model that we can based on the accuracy. Like we used various NLP techniques like sentiment analysis and TF, IDF, but found out that it was overfitting a data set. So we needed to drop it and use only the primitive features. So our final model uses a ReLU activation function and the Adam solver. We got approx 80% accuracy on a data set.
To conclude, the proposed fake news analysis model provides a method to collect tweets, see tweets, and user information used to identify, analyze, and visualize the best features having influence in the propagation of news. These may include existence and absence of information source, replies and influencing power of tweets, rate of using seed tweets, then depth of tweet propagation tree, rate of quoting pictures, videos, etc. Our analysis shows that fake and real news exhibit significant differences in engagement and source characteristics. Fake tweets propagated for longer periods gradually but constantly as compared to real tweets. With the possibility to categorize the propagated news into real and fake, we may reduce, if not prevent, the spread of fake news. While our model does not propose 100% accuracy, it's a small step towards that goal.